So this time we want to talk about what if the degree of the numerator is greater than the denominator for the infinite limit at infinity. Okay, so when you look at the first example, as you see, the numerator degree is bigger than denominators, right? So this case, we cannot apply the like a horizontal asymptote theory, which is the numerator degree is smaller than denominators, then always 0 is the limit, and then the same degree than their coefficient. But this time, as you see, the numerator degree is greater than denominators. So this type of case, we can find out their slant asymptote. Okay, then let's talk about how to find it. So first of all, you are dividing this numerator function by the denominator, because whenever you need to confirm the limit value, then we better make the constant value or regular polynomial expression plus the fraction form as well. So I'm gonna do that. So maybe 2x squared minus 4x divided by x plus 1. Then as you see, x goes to 2x squared twice, so 2x, then 2x squared, and then plus 2x, and you subtract, then this is gone, so minus 6x so far, right? Okay, then now this one minus 6, then this become negative 6x minus 6, and then now you subtract, which means change their sign, so this is gone, so 6 is left over. Therefore, this limit, you can rewrite that limit x move to infinity, 2x minus 6 plus 6 over x plus 1, like that. Okay, so in this case, there will be your slant asymptote, basically. So now, so this question asks you, from the positive side and negative side here, and this is already 0. So limit x move to infinity, 2x minus 6 plus 6 over x plus 1. You can just ignore this one because it becomes automatically 0. And then now this is the increasing, because this is a positive, so increasing graph. So this limit become positive infinity. Okay. Then now, what about this case here? So the same question, but the limit is negative side, right? And then this is a linear, which means if I draw the graph here, it looks like somehow this. So it's going down here, negative side forever. So this limit become negative infinity. Okay, so then let's look at one more questions. So like this, there are 3 different scenarios here. So A case, even though this is the first term, but this is our leading term. Makes sense, right? Then now, first of all, compare their leading degree between the numerator and denominators. Okay, numerator 3 over 2 and denominator 2, which means 4 over 2, right? So since this is greater, therefore this limit becomes 0 no matter what. Okay, what about this case? This case, we have exactly same degree value here, therefore this limit become their coefficient, which is negative 2 over 3. What about this case? So as you see, so 3 over 2 is bigger than 1, or equal to 2 over 2. So you need to find out the slant asymptote. So what I want to do, I'm going to make division of this fractional expression, and then find out the slant asymptote. Oops. So actually I'm going to write So negative 2x 3 over 2 plus 5 divided by 3x minus 4, sorry, 3x minus 4. Okay, so first of all, we want to make 2. Then you need to make 2 over 3 first of all, and then we need 1 over 2 more, so x to the 1 over 2 power. Then this becomes, is actually negative, then negative 2x 3 over 2, and then plus 4, so 8 over 3 x to the 1 over 2. Okay, then if you just subtract, which means change their sign, then this is gone, so become 8 over 3 x 1 over 2 plus 5 here. Okay, so now this one you can rewrite that. So limit x move to infinity, negative 2 over 3 x 1 over 2 and plus 8 over 3 x 1 over 2 plus 5 over 3x minus 4. But as you know, the leading degree is, this is smaller than this one, so no matter what, this will be 0. Then we only care about this part here. Okay, so when you look at this graph, the graph looks like this. Okay, so I'm gonna move a little bit here. Then as you see, this going to like negative infinity, because even though this is the like bluntly decreasing, but whenever it go to infinite side, then the value get decrease and decrease. So I can say this one is negative infinity. So I can say, so that's the limit become negative infinity basically. That's the answer for this problem. So like now, so we cover all 3 different scenarios when the numerator degree is smaller than denominators, and whenever they are equal to each other, or the numerator degree is smaller than denominators. So summary is, if the numerator degree is smaller than denominators, no matter what, limit becomes 0. But the degree of numerator and denominator equal to each other, then take their coefficient. But last case, if the numerator degree is bigger than denominators, then you need to make a division and find the function that represent the limit value, and then the rational part is always become the 0. Okay, that's the infinite limit theory. All right, thank you.